Hello, everyone. Welcome to this public lecture. My name is Eugene Nagasawa. I'm professor of philosophy and co-director of the John Hick Center for Philosophy of Religion at the University of Birmingham. I'm one of the organizers of this event. It's my great pleasure and great honor to introduce Professor William Lane Craig tonight. Professor Craig is currently research professor of philosophy at Talbot School of Theology and professor of philosophy at Houston Baptist University. He did his PhD at the University of Birmingham under the supervision of the late John Hick. Professor Craig has published over 30 books, including The Clam Cosmological Argument, Time and Eternity, and Reasonable Faith. He has also authored more than 100 articles in professional journals, including the Journal of Philosophy, New Testament Studies, and the British Journal for Philosophy of Science. Professor Craig is now recognized as one of the most influential philosophers of religion. The topic of Professor Craig's lecture tonight is the Clam Cosmological Argument, which was originally introduced by medieval Islamic theologians. Professor Craig has developed a contemporary version of this argument and significantly strengthened the argument by incorporating contemporary Big Bang cosmology and the mathematics of infinity. The Clam Cosmological Argument is now one of the most discussed arguments for the existence of God. Ladies and gentlemen, please welcome Professor William Lane Craig.
Thank you very much. Thank you very much. I have so enjoyed delivering the Cadbury lectures this week at the University of Birmingham, and was delighted that Professor Nagasawa invited me to give this public lecture on the Clam cosmological argument as well. And I'm looking forward to a stimulating evening together. As a boy, I wondered at the existence of the universe. I wondered where it came from. Did it have a beginning? Has it always existed? I remember lying in bed at night trying to think of a beginningless universe. Every event would be preceded by another event, back and back into the past, with no stopping point, or more accurately, no starting point. An infinite past with no beginning. My mind reeled at the prospect. It just seemed to me inconceivable. There must have been a beginning at some point, I thought, in order for everything to get started. Ancient Greek philosophers believed that matter was necessary and uncreated, and therefore eternal. God may be responsible for introducing order into the cosmos, but he did not create the universe itself. This Greek view was in contrast to even more ancient Jewish thinking about the subject. Hebrew writers held that the universe has not always existed, but was created by God at some point in the past. As the first verse of the Hebrew Holy Scriptures states, "In the beginning, God created the heavens and the earth." Genesis 1:1. Eventually, these two competing traditions began to interact. There arose within Western philosophy an ongoing debate that lasted for well over 1,000 years about whether or not the universe had a beginning. This debate played itself out among Jews and Muslims, as well as Christians, both Catholic and Protestant. It finally sputtered to something of an inconclusive end in the thought of the great 18th century German philosopher Immanuel Kant. He held, ironically, that there are rationally compelling arguments on both sides thereby exposing the bankruptcy of reason itself. I first became aware of this debate only after graduating from university. Wanting to come to terms with this question, I decided upon the completion of my master's degree work in philosophy to find someone who would be willing to supervise a doctoral thesis on this question. I was able to explore the historical roots of the argument, as well as deepen and advance the analysis of the argument. I also discovered quite amazing connections to contemporary astronomy and astrophysics. Because of the historic roots in medieval Islamic theology, I christened the argument the Kalam cosmological argument. Kalam is the Arabic word for medieval theology. Today, this argument, largely forgotten since the time of Kant, is once again back at center stage. The Cambridge Companion to Atheism in 2007 reports, a count of the articles in the philosophy journals shows that more articles have been published about the Kalam argument that have been published about any other contemporary formulation of an argument for God's existence. Theists and atheists alike cannot leave the Kalam argument alone. What is the argument that has stirred such interest? Well, let's allow one of the greatest medieval protagonists in this debate to speak for himself. Al-Ghazali was a 12th century Muslim theologian from Persia, or modern-day Iran. He was concerned that Muslim philosophers of his day were being influenced by ancient Greek philosophy to deny God's creation of the universe. After thoroughly studying the writings of these philosophers, Ghazali wrote a withering critique of their views entitled The Incoherence of the Philosophers. In this fascinating book, he argues that the idea of a beginningless universe is absurd. The universe must have had a beginning, and since nothing begins to exist without a cause, there must be a transcendent creator of the universe. Ghazali formulates his argument very simply. I quote, "Every being which begins has a cause for its beginning. Now the world is a being which begins, therefore it possesses a cause for its beginning." Ghazali's reasoning involves three simple steps. Premise one, whatever begins to exist has a cause of its beginning. Premise two, the universe began to exist, from which it follows three, therefore the universe has a cause of its beginning. Let's look at each premise of this argument. Notice that Ghazali does not need a premise so strong as one in order for his argument to succeed. The first premise can be stated more modestly as 1 prime. If the universe began to exist, then the universe has a cause of its beginning. As Christopher Isham, Britain's premier quantum cosmologist, cautions, care is needed when using the word creation in a physical context. One familiar example is the creation of elementary particles in an accelerator. However, what occurs in this situation is the conversion of one type of matter into another, with the total amount of energy being preserved in the process. Thus, this alleged exception to 1 is not an exception to 1 prime. Let me give 3 reasons in support of premise 1 prime. First, something cannot come from nothing. To claim that something can come into being from nothing is worse than magic. When a magician pulls a rabbit out of a hat, at least you've got the magician, not to mention the hat. But if you deny premise 1 prime, you've got to think that the whole universe just appeared at some point in the past for no reason whatsoever. But nobody sincerely believes that things, say a horse or an Eskimo village, can just pop into being without a cause. Second, if something can come into being from nothing, then it becomes inexplicable why just anything and everything doesn't come into being from nothing. Think about it. Why don't bicycles and Beethoven and root beer come into being out of nothing? Why is it only universes that can come into being from nothing? What makes nothingness so discriminatory? There can't be anything about nothingness that favors universes, for nothingness doesn't have any properties, nor can anything constrain nothingness, since there isn't anything to be constrained. Thirdly, common experience and scientific evidence confirm the truth of premise 1 prime. The science of cosmogony is based on the assumption that there are causal conditions for the origin of the universe. So it's hard to understand how anyone committed to modern science could deny that 1 prime is more plausibly true than false. So I think that the first premise of the Kalam cosmological argument is surely true. The more controversial premise in the argument is premise 2, that the universe began to exist. This is by no means obvious. So let's examine both philosophical arguments and scientific evidence in support of premise 2. First, the philosophical arguments. Ghazali argued that if the universe never began to exist, then there has been an infinite number of past events prior to today. But, he argued, an infinite number of things cannot exist. Ghazali recognized that a potentially infinite number of things could exist, but he denied that an actually infinite number of things could exist. When we say that something is potentially infinite, infinity serves merely as an ideal limit which is never reached. For example, you could divide any finite distance in half, then into fourths, then into eighths, then into sixteenths, and so on to infinity. The number of divisions is potentially infinite in the sense that you could go on dividing endlessly, but you would never arrive at an infinity-th division. You would never have an actually infinite number of parts or divisions. Now, Ghazali has no problem with the existence of a merely potential infinite, for these are just ideal limits. But he argued that if an actually infinite number of things could exist, then various absurdities would result. If we're to avoid these absurdities, then we must deny that an actually infinite number of things exist. That implies that the number of past events cannot be actually infinite. Therefore, the universe cannot be beginningless. Rather, the universe began to exist. So I think that Ghazali's first argument is a good one. It shows that the number of past events must be finite. Therefore, the universe must have had a beginning. We can summarize Ghazali's argument as follows. Premise 1, an actual infinite cannot exist. 2, an infinite temporal regress of events is an actual infinite. 3, therefore, an infinite temporal regress of events cannot exist. In addition to this argument, Ghazali has a second, independent argument for the beginning of the universe. The series of past events, Ghazali observes, has been formed by adding one event after another. The series of past events is like a sequence of dominoes, falling one after another until the last domino, today, is reached. But, he argues, no series which is formed by adding one member after another can be actually infinite, for you cannot pass through an infinite number of elements one at a time. This is easy to see in the case of trying to count to infinity. No matter how high you count, there is always an infinity of numbers left to count. But if you can't count to infinity, How could you count down from infinity? This would be like someone's claiming to have counted down all the negative numbers ending at 0. -3, -2, -1, 0. This seems crazy. For before he could count 0, he would have to count -1. And before he could count -1, he would have to count -2. Before he could count -2, he would have to count -3, and so on, back to infinity. Before any number could be counted, an infinity of numbers would have to have been counted first. You just get driven back and back into the past so that no number could ever be counted. But then the final domino could never fall if an infinite number of dominoes had to fall first. So today could never be reached. But obviously, here we are. This shows that the series of past events must be finite and have a beginning. Ghazali thought to heighten the impossibility of forming an infinite past by giving illustrations of the absurdities that would result if it could be done. For example, suppose we meet someone who claims to have been counting down from eternity past and is now finishing. -3, -2, -1, 0. Why, we may ask, is he just finishing his countdown today? Why didn't he finish yesterday? Or the day before that? After all, by then, an infinite amount of time had already elapsed. So if the man were counting at the rate of 1 number per second, he's already had an infinite number of seconds to finish his countdown. He should already be done. In fact, at any point in the past, he has already had infinite time, and so should already have finished. But then, at no point in the past can we find the man finishing his countdown, which contradicts the hypothesis that he has been counting from eternity past. These illustrations only strengthen Ghazali's claim that no series which is formed by adding one member after another can be actually infinite. Since the series of past events has been formed by adding one member after another, it can't be actually infinite. It must have had a beginning. And so we have a second good argument for premise 2, that the universe began to exist. We can summarize this argument as follows. 1, a collection formed by successive addition cannot be an actual infinite. 2, the temporal series of events is a collection formed by successive addition. 3, therefore, the temporal series of events cannot be an actual infinite. One of the most astonishing developments of modern astronomy, which Ghazali could never have anticipated, is that we now have strong scientific evidence as well for the beginning of the universe. The first scientific confirmation of the universe's beginning comes from the expansion of the universe. All throughout history, men have assumed that the universe as a whole was unchanging. Of course, things in the universe were moving about and changing, but the universe itself was just there, so to speak. This was also Albert Einstein's assumption when he first began to apply his new theory of gravity, called the general theory of relativity, to the universe in 1917. But Einstein found that there was something terribly amiss. His equations described a universe which was either blowing up like a balloon or else collapsing in upon itself. During the 1920s, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre decided to take Einstein's equations at face value, and as a result, they came up independently with models of an expanding universe. In 1929, the American astronomer Edwin Hubble, through tireless observations at Mount Wilson Observatory, made a startling discovery which verified Friedmann and Lemaitre's theory. He found that the light from distant galaxies appears to be redder than expected. This red shift in the light was most plausibly due to the stretching of the light waves as the galaxies are moving away from us. Wherever Hubble trained his telescope in the night sky, he observed this same red shift in the light from the galaxies. It appeared that we are at the center of a cosmic explosion, and all the other galaxies are flying away from us at fantastic speeds. Now, according to the Friedmann-Lemaitre model, we're not really at the center of the universe. Rather, an observer in any galaxy will look out and see the other galaxies receding from him. This is because, according to the theory, it is really space itself which is expanding. The galaxies are actually at rest in space, but they recede from one another as space itself expands. The Friedmann-Lemaitre model eventually came to be known as the Big Bang theory. The standard Big Bang model thus predicts an absolute beginning to the universe. If this model is correct, then we have amazing scientific confirmation of the second premise of the Kalam cosmological argument. As if this weren't enough, there's actually a second scientific confirmation of the beginning of the universe, this one from the second law of thermodynamics. According to the second law, unless energy is being fed into a system, the system will become increasingly disorderly. Now, already in the 19th century, scientists realized that the second law implied a grim prediction for the future of the universe. Given enough time, all the energy in the universe will spread itself out evenly throughout the universe. The universe will become a featureless soup in which no life is possible. Once the universe reaches such a state, no significant further change is possible. It is a state of equilibrium. Scientists called this the heat death of the universe. But this unwelcome prediction raised a further puzzle. If given enough time, the universe will inevitably stagnate in a state of heat death, then why, if it has existed forever, is it not now in a state of heat death? If in a finite amount of time the universe will reach equilibrium, then given infinite past time, it should by now already be in a state of equilibrium. But it's not. We're in a state of disequilibrium, where energy is still available to be used, and the universe has an orderly structure. So, once again, the scientific evidence confirms the truth of the second premise of Ghazali's cosmological argument. On the basis, therefore, of both philosophical and scientific evidence, we have good grounds for believing that the universe began to exist. It therefore follows logically that the universe has a cause of its beginning. What properties must this cause of the universe possess? This cause must itself be uncaused, because we've seen that an infinite series of causes is impossible. It is therefore the uncaused first cause. It must transcend space and time, since it created space and time. Therefore, it must be immaterial and non-physical. It must be unimaginably powerful, since it created all matter and energy. Finally, Ghazali argued that this uncaused first cause must also be a personal being. The Kalam cosmological argument thus gives us powerful grounds for believing in the existence of a beginningless, uncaused, timeless, spaceless, changeless, immaterial, enormously powerful, personal creator of the universe. And that is what everybody means by God.